right, this is number 3 from the review for quiz 7173. And we have 2 functions here, and we're just looking for their intersection to find these things out. So what I did first was I put them on the calculator. I went ahead and graphed it in a regular window and saw a little bit more, and then I was able to narrow in on a 0 to 5 for x and a -6 to 6 for y. And when I graphed it, it kind of looked like this shape here, right? So this is what we're dealing with in terms of the region, and the first thing we're asked to do is find the area. So if I do a rectangle in here, the length of that rectangle will be top minus bottom. The bottom is a negative value, so when you do minus bottom, you will make it a positive thing, which will give us this distance. So you never want to change, even though it is below the x-axis, don't double cross yourself there. It's still going to be top minus bottom. So we still want f minus g here. That's the height of the rectangle. dx will be that'll give us an area of the rectangle. We're going to add up all the rectangles from start to finish. Now we do want to know where that is. We can make an assumption, but we always want to kind of just make sure. So let's bring this down a little bit here and enter, enter, enter. Tells us that for sure we get an intersection. It might not show it here because it's right on the edge of mine. Nope, we ended up getting it. 0 is the first intersection point. So we know that we intersected 0, so that'll be our lower limit. Okay. And again, we could make an assumption on the other one, but let's just make sure if I intersect and then kind of just climb up and over to this other point. Again, we just kind of want to double check to make sure that we aren't assuming anything. Enter, enter, enter. And this will tell us that we intersect over here at, I believe we'll see that we intersect at 5. And sure enough, that's what it says. All right. So we're going from 0 to 5. And again, I just wanted to check just in case. You never know. So now I can go math 9, 0 to 5, f1, or f of x minus g of x dx, enter. And I get 35.901 if we round it. All right, so not too bad. Pretty easy one. What's the volume if we spin this around the line y equal 8? So in terms of what we're looking at, we have this here and this here. Now y over 8, y equal 8 is there. So when we spin that, we're going to get a big radius, which goes from here to the outer edge. That'll be the g function now. 8 is this total distance, and we're going to subtract the g function because, again, g is negative. So by subtracting g, we'll actually create a positive value to add on to there. So if we go 8 minus g, that will be the big radius. Again, you can turn yourself all around, all crazy like, because it's below the x-axis, but in truth, it doesn't matter where it's oriented. It's always, when they're above like this, it's always going to be the value minus the outer one, minus that value minus the inner one. Okay, we can still treat it the same way, whether it's above, below, or right through the x-axis, doesn't matter. Okay, so this is our setup. So take the calculator, go pi, math 9, 0 to 5. And we're going to go 8 minus y2 squared minus 8 minus y1 squared dx. Enter. And we get 1,734.946. All right, that's what we get for that. Then the last one here says it's the base of a solid. So let's draw this again. So if I cut this at a certain part, I'm cutting into a solid, and what we're being told is that this cross section we'd see is a semicircle. Okay, so pull that semicircle over to the side here. This part of it is that right there. And so the top minus bottom, f minus g, would represent the entire distance from here to here, the diameter of that semicircle. I want the area of this right here. So area of a circle is pi times radius squared. Now the radius is not f minus g. F minus g is the diameter. The radius would be half of this. So I'm going to take f minus g and cut it in half. and that would give me the radius. So now pi times this radius squared, that would be for the whole circle. But we aren't dealing with the whole circle, we're only doing with half of it. So I need a half on there to give me the semicircle. Now that right there would represent the area of that little circle. If I do a dx, that'll give me a volume. And if we sum all of that up from 0 to 5, that'll be all the semicircles and give us the whole volume. So I can go 0.5 pi math 9 0 to 5 of, in parentheses, we're going to go, I'm going to do 2 parentheses, one for top minus bottom. Had to think it through a little bit. Divided by 2, that'll be the next parentheses, and then we're going to square that. And we end up with 123.111. That'll be our volume. So that's number 3.